Let's look at this example. 5x times parentheses 2x minus 3 plus 7x is equal to 2 times parentheses 4x squared minus 29. So whenever you see parentheses and then there are like 5x or there's like some number in front of the parentheses, we should always just distribute and then combine terms. 5x will take this and multiply with 2x. We get 10x squared. And then you take 5x, you multiply with negative 3, you get minus 15x, and then that's it. Bring down the plus 7x, and then bring down the equal sign. I see the 2 in front of this parentheses. I will take the 2, multiply the inside here, and then multiply inside there. I get 2 times that, which is ax squared. 2 times that is negative 58. Okay? So again, we end up with a quadratic equation, and let's just move all the numbers. Let's move all the things to the left hand side first. Okay? So let me minus ax here, ax squared there, ax squared here. Cancel this, cancel that. So here we get, this is 2x squared, right? 10x squared minus ax is 2x squared. But then on this side, we have the negative 15x combined with the positive 7x. So that's the result of negative 8x. And depends on which method that you would like to use. If you want to talk about completing a square, we should just write it as 2x squared minus ax. And since the number is on the right hand side already, let's just bring down minus 58 like this. Unless you want to use quadratic formula, then you will have to make one side equal to 0. Or if you want to use factoring, then make one side equal to 0. But I think for this video, let's do this by completing the square. If we want to do completing the square, we need to have the x squared plus bx on one side. And we almost have it, because here we only have 2x squared, but we just want x squared, right? So we want to divide by 2 for these three numbers. So divide by 2, we can cancel the 2's, and then I also have to do the same for the rest. Divide by 2. Okay. And I will get x squared minus, this is negative 8 divided by 2, which is minus 4x, and that will equal to negative 29. So we got it, x squared plus bx on the left hand side. And what we need to do is, and you see how I purposely leave a space right here, because we need to think about what number should add on both sides, and then the left hand side will be, factorable, and you will factor into a perfect square. To figure that out, we will need to note what's the value of b, and b is a number in front of the x. B is the number in front of the x. So in this case, b is equal to negative 4. Okay. Then on the side, let me figure out what's this 1/2 times b and then square. So I will do so on the side. 1/2 times b parentheses square. And then this will be 1/2 times b is negative 4. So let me put down negative 4 here, square. And inside 1/2 times negative 4, you can write this as negative 4 over 1, and can cancel this with that. So you get negative 2 inside, square. Okay, you get negative 2 inside, square. And negative 2 squared, this is just negative 2 times negative 2. We get positive 4. And you should always end up with a positive number here. And let me box this, just my scratch work. This is the result I'm going to add it on both sides. Plus 4 here and plus 4 here. Okay. So after I add the 4, the left hand side, this part right here, it's always going to factorable. If it's not, then we did something wrong. So the next step is we are going to factor the left hand side. And even better, it's always going to be something inside to the second power. We can always check, but you can also trust yourself, okay, if you did all the steps correctly. But it's always good to check. To factor this out, let's see, parentheses, I will have the x and x, and to get positive 4, I will need a 2 and 2, right? 2 times 2 is equal to 4. But I want to have a negative 4 at the end, so let's put negative 2, right? So on the left hand side, I have x minus 2 times x minus 2. So just as we said, since these two are the same, we can just write that as something inside. We can write this as x minus 2 square. Another way to get this, you see how I make the negative 2 in red in here. Another way to get this is to just look at this number. And I think, again, this is one of the reasons why you should always show your step. Because in our case, our step, which is this part right here, this negative 2 right here, this negative 2 right here, this is going to help us to continue with our question. Okay? And you see that it also works. So you can also factor it out and double check as well. So now I need this. So just look at this. Aha. X minus 2 squared. This is equal to negative 29 plus 4, which is negative 25. So a perfect square, something inside to the second power, is equal to a number. And then we're just going to square root both sides, and don't forget the plus minus, and then solve it. So take the square root here, and take the square root here. Put the plus minus on the number, with the numbers. Square root cancels, I will just get x minus 2 equals to, and now let's see. Let me bring down the plus minus sign first. We have square root of negative 25. Whenever you see a negative inside of the square root, especially when you learn the complex number, square root of negative numbers, you should just put an I on the outside first. Okay? So when you see a negative inside of the square root, you should have an I ready. Okay? So the I is ready now, and then you should just do square root of 25. It turns out to be just a nice number 5. So it's like I times 5. Or you can also write this as 5i. To isolate x, to finish this question, we just need to plus 2 on both sides. And so this final answer, x equals to 2 plus or minus 5i. Usually we should write the number first before like any letters. So 5i. So this is a complex number. We cannot combine like terms. We will just leave the answer like this. And let me make a note. This notation means we have two solutions. Let me make a note right here. This notation means that we have two solutions. First solution is 2 plus 5i. Okay, as the first solution. Or the second solution is 2 minus 5i. And unfortunately, or actually I should have said, it's actually better that we cannot combine terms, because we can just leave the answer like that. But if this is something else that we can actually combine terms, then you have to keep going and then combine like terms, reduce the fractions or things like that. And this is example number 6.